Thank you. Okay, this is the second of 4 sections that we're covering in this chapter. Now for 16.2, we'll be thinking about coordinate systems and points. CNC machines move and locate with reference to the axis origin. They move to locations identified with co-coordinates. Co means working together. Ordinate means a single line of position. For example, on a flat screen, you have, this is an ordinate, the point to be identified lies somewhere along it. Let's say that the line is parallel to the x-axis and 1.750 above the xy origin. This line is parallel to the y-axis and lies 2.50 to the right of the xy origin. So now we're starting to get some insight into the nomenclature of how we're going to be categorizing what it means in terms of movement and location. This point is identified with a set of coordinates on this plane. So for absolute value coordinates in CNC work, the place where the coordinates are x0, y0, and z0 is known as the program reference 0, PRZ. It's a starting point for coordinates. Most coordinates in the program refer to their distance from the PRZ. So where it all begins, you may hear different terms for PRZ, program 0, program data point, the origin, a math term, or others, depending on the region in which you live. PRZ is the most common used, but they all mean the same. And so here you can be seeing how that would lay out. So the tip of the drill is at x2.2.5, y1.00, and z minus 1.00 relative to P or Z, which is on top of the corner of the part. So you can be thinking about that, but here we're starting to get some ideas of when we start to put these things together. When we want coordinates to refer to the P or Z, we put a code in the program. G90 tells the control this and all others until changed are absolute values. CAM programs are almost all absolute values. So for quadrants and absolute values, when moving across the origin line using absolute coordinates, the plus and minus value change depending on the quarter circle quadrant in which the point lies. And so, for example, go to the next slide. Now we see these 4 different quadrants, and we can start to be observing where point A, B, C, and D are. So for point A, it has both positive X and Y. So it's X 1.54 and y 1.13. C has both negative x and y, so we have to put in this minus sign. So C is x minus 1.54 y minus 1.13. And so you can be thinking about how we would come up with the designations for B and D. So one's going to be positive, one's going to be negative, and hopefully this diagram will help you to figure those out on your own. You can pause the video and try and do that if you would like. So for incremental value coordinates, occasionally we encounter the need for a different kind of coordinate. They do not refer to the PRZ, but rather to their last position. So you have a relative positioning scheme that's possible. Incremental coordinates are jumps from where you are to where you wish to go next. So these are also called relative coordinates since they relate to the current location for the reference. So incremental coordinates are useful for hand compiling small setup or tooling programs written by the machinist at the machine. They are also used in a limited number of commands that we'll study later. To use incremental coordinates in a program, the control must be read a G91 code or be told in some other way that they are not absolute. So now you're starting to get a little bit of an idea of the kind of syntax we'll be doing for CNC programming. So here you would see G91, relative position, x minus 1.00. So what about significant points? To go to a position either at a rapid rate or at a feed rate, we use significant points on the part geometry to create a program coordinates. So we have to let it know how we go from one point to another. So you finish machining in one area, you need to move the drill to another. And so that's the area that we're starting to explore here. Points occur at ends of lines and arcs. They also occur at the center of arcs and at the tangent points where lines are joined. And so here we can be starting to think about how we would start to be machining more complicated parts like what we're starting to show with this diagram. Okay, let's break and we'll come back to this with the next little snippet.